Hi students, today we are going to see the session 6 homogeneous partial differential equation. An equation of the form a into dou square z by dou x square plus b into dou square z by dou y dou x plus c into dou square z by dou y square is equal to f of x comma y is called the homogeneous second order partial differential equation. This can be written as a into d square plus b into d dash plus c into d dash square into z is equal to capital F of x comma y, where d is equal to dou by dou x and d dash is equal to dou by dou y. So previously we saw the ordinary differential equation. So there we have only the d and constant term. Here we have a d dash is having, that is here the partial differential equation we have the more than one independent variable is having. So therefore we have d and d dash is having. So the same procedure what we did in the ordinary differential equation. So the same way here we are going to use. The homogeneous partial differential equation means all the order is same. Here also order 2, here is also order 2, here is also order 2. So if all the orders are same, therefore the given differential equation is a homogeneous differential equation. So for solving this homogeneous differential equation, we have a two parts. One is a complementary function, another one is a particular integral. Next we are going to look in the problem. Find complementary function and particular integral for the partial differential equation d cube minus 7 dd dash square minus 6 d dash cube into z is equal to x square y plus sine of x plus 2y. So consider this as a given equation. Now we are going to write the auxiliary equation. So in ordinary differential equation, we just replace d by m. But here in the homogeneous PDE, we just replace capital D by m and capital D dash by 1. So we get the auxiliary equation as m cube minus 7m minus 6 equal to 0. So now we are going to solve this equation. So you will get the three values for m because here the highest degree is 3 having. So first we have to use by trial and error method. If you put m is equal to 1, you should not get the values, the equation not equal to 0. If you put m is equal to minus 1, so minus 1 the whole cube is minus 1. Here minus 7 into minus 1 get the plus 7, then minus 6. So minus 7 plus 7 equal to 0. Therefore m is equal to minus 1 is a root. So another two roots we are going to calculate by using the synthetic division method. So coefficient of m cube is 1. The coefficient of m square is not having. So in that place put 0. Then coefficient of m is minus 7. Then the constant value is minus 6. So here if you substitute m is equal to minus 1, then the equation 1 satisfies. So therefore you consider that value minus 1. So here first value always put the 0. So add these two, 1 plus 0 you get the 1. Now these two have to multiply. 1 into minus 1 minus 1. 0 plus minus 1 minus 1. Minus 1 into minus 1 plus 1. Minus 7 plus 1 minus 6. Then minus 6 into minus 1 plus 6. So minus 6 plus 6, 0. So now we have to write this as a quadratic equation. M square minus m minus 6 equal to 0. So solving this quadratic equation, we get the m is equal to 2, 3. Then now we are going to write the complementary function. So complementary function is equal to f1 of y minus x plus f2 of y plus 2x then plus f3 of y plus 3x. So now we are going to find the particular integral. So there in a given question we have a two particular integral is having. So this one you consider as particular integral 1. This one I consider as a particular integral 2. So now we are going to find the particular integral for first one. D cube minus 7 d dash square minus 6 d dash cube into x square by. So here I have to take out the d cube outside. So this can be written as 1 minus 7 d dash square by d square minus 6 d dash cube by d cube. So from both the term minus is common. So take out the minus outside. So minus of 7 d dash square by d square plus 6 d dash cube by d cube of x square by. So this 1 minus x form is having. If this term take it to the numerator, so can be written as whole power minus 1. So this is of the binomial expansion 1 minus x whole power minus 1. We know the formula for binomial expansion 1 minus x whole power minus 1 equal to 1 plus x square plus x cube plus etc. So now after expanding this as a binomial expansion, so first one 1 into x square y is x square y. Then d dash is nothing but differentiation with respect to y. So first time if you differentiate, you will get the 1. Second time if you differentiate, become a 0. Then the third time is also differentiation of y is 0. So therefore, in this place, the first this term is also 0, this term is also 0. So one day you get the x square y. So now we have to integrate this one thrice. That is the first time integrate, you will get the x cube y by 3. Again integrate, you get the x power 4 by 12. Again integrate, you will get the x power 5 by y. X power 5 y by 60. So this is the PI1. Next we are going to find the PI2. So 1 by d cube minus 7 dd dash square minus 6 d dash cube into sine of x plus 2y. So we already see that ordinary differential equation. There sine, either if we have a sine or cos, replace d square by minus 1. Here the partial differential equation, we have to replace d square by minus 1 and d dash square by minus 4 and d dash by minus 2. So after this one, so here d cube can be written as d square into d. So instead of d square, we replace minus 1. So remaining will get the minus d. Then here d dash square can be written as d dash into d dash. D dash we have to replace as minus 2. So minus 7 into minus 2 into d dash plus here also we have to replace d dash square by minus 4. Minus 4 into d dash will get. So already minus is having. So plus 24 d dash into sine of x plus 2y. Then after simplifying we get minus d plus 14 d dash plus 24 d dash. So add these two will get the 38 d dash. So after this one we have to take the conjugate of this one. So what is the conjugate of this one? So minus d minus 38 d dash. So multiply the conjugate by numerator and denominator. So in the denominator we got the result as d square minus 1444 d dash square into sine of x plus 2y. So again have to use the same procedure. Replace d square by minus 1, d dash square by minus 4. So after replacing we get the result as 5775 in the denominator. So numerator d of sine is, that is differentiation of sine. So differentiation of sine is cos. Cos of x plus 2y into, with respect to x we have to write as x is 1. Next one, d dash is nothing but differentiation with respect to y. So differentiation with respect to y. So cos of x plus 2y into 2. So both you have to add, then we'll get the minus 77 by 5775 into cos of x plus 2y. So finally we have to write the solution as z is equal to complementary function plus particular integral. Next we go look into the another problem. Using auxiliary equation, find the general solution of d square plus 4dd dash minus 5d dash square into z is equal to e power 2x minus y plus sine of x minus 2y. So consider as a given equation. So now we are going to write the auxiliary equation. So auxiliary equation I already explained. Replace d by m, d dash by 1. So can be written as m square plus 4m minus 5 equal to 0. So solve this quadratic equation. We get the two roots for m. So now we are going to write the complementary function. So CF is equal to f1 of y plus x plus f2 of y minus 5x. So here two particular integral is given. So we are going to find the particular integral 1. So 1 by d square plus 4 dd dash minus 5 d dash square into e power 2x minus y. So the same procedure we did in the ordinary differential equation. Just to replace d by, what is the coefficient of x having? 2. So just to replace. And the same way, what is the coefficient of y is having? Minus 1. That we have to replace by d dash. So we get the 2 the whole square plus 4 into 2 minus 1 minus 5 into minus 1 the whole square. So can be written as 4 minus 8 then minus 5 into e power 2x minus y. So we get the 1 by minus 9 into e power 2x minus y. So next we are going to see the another PI. 1 by d square plus 4 dd dash minus 5 d dash square into sine of x minus 2y. So here also replace d square by minus 1, dd dash by 2, then d dash square by minus 4. So d square by minus 1, so minus 1, dd dash by 2. So 4 2s are 8 minus 5 into minus 4, you get the plus 20 sine of x minus 2y. So the value is 1 by 27 into sine of x minus 2y. Therefore, the solution is equal to z is equal to complementary function plus particular integral. Next we go to the another problem. Dou solve dou square z by dou x square plus dou square z by dou x dou y minus 6 into dou square z by dou y square is equal to y cos x. So consider as a given equation. Now we are going to write the auxiliary equation m square plus m minus 6 equal to 0. So solve this equation, we get m is equal to 2 comma minus 3. Then write the complementary function f1 of y plus 2x plus f2 of y minus 3x. So now we are going to find the particular integral. So here we have the another type. So previously we saw that e power and sine. Here multiple of y into cos x is having. So now we have to split this denominator according to this value of m. We can write d plus 2d dash d minus 3d dash. Split and write. Then now we have to replace instead of this y as c minus 3x. I am considering this d minus 3d dash. So here we have to replace y as c minus 3x into cos x dx. So this one you have to integrate by using the integration by parts formula u v1. So integration of cos is sine plus cos 3x cos x into differentiation of 3x is minus 3 will get. So I have to write the plus 3. Then after this one finally replace this y sin x plus 3 cos x. Again for this term you have to put the integral of c plus 2x. So here we have a d minus 3 dash, or can written as c minus 3x. Here we have a d plus 2d dash is having, so can be written as c plus 2x into sin x plus 3 cos x into dx. So you have to these two terms you have to integrate by using integration by parts. Then this one you have to usual integration. We get the sin x. Then now replace c plus 2x as y. So minus y cos x plus 5 sin x. Therefore the solution is z is equal to f1 of y plus 2x plus f2 of y minus 3x minus y cos x plus 5 sin x. That's all. So up to this homogeneous partial differential equation is over. So now we are going to the non-homogeneous partial differential equation. So non-homogeneous partial differential equation is nothing but in which the order of the derivative is not same is called the non-homogeneous partial differential equation. So the homogeneous, the order of the derivatives is same. Here the order of the derivatives is not same. So here we have a two cases is having. So finding the complementary function. If d minus m1 d dash minus alpha 1 d minus m2 d dash minus alpha 2 is equal to f of x comma y, then complementary function z is equal to e power alpha 1x f1 of y plus mx m1x plus e power alpha 2x f2 of y plus m2x. Next case 2, if you have the repeated value, that is a whole square if we got, we can write e power alpha x into f1 of y plus mx plus x into e power alpha x f2 of y plus mx. So next we are going to look into the problem. So here the complementary function is different for this non-homogeneous, but particular integral is same for what we did in the homogeneous, the same is for non-homogeneous also. So now consider the left hand side of the given differential equation. So here see, look at here, d square, here the power is 2, the order of derivative is 2, here the order of derivative 2, here also the order of derivative 2. So here order of derivative is 1, here also order of the derivative is 1. For all the terms the order of derivatives is not same. So therefore this comes under the non-homogeneous type. So now we have to split this term as d minus m1 d dash minus alpha 1 like that form we have to split. So for that one we have to consider this given equation as a quadratic equation in capital D. So we know the finding the quadratic equation d is equal to minus b plus or minus root of b square minus 4ac by 2a. So that form you have to do this one. A is consider here find out a is equal to 2, b is equal to minus d dash minus 6, c is equal to minus d dash square into 3d dash. So substitute here, we find the value finally 4d dash minus 12 by 4 minus 2d dash by 4. So divide by 4, we'll get the d dash minus 3 into d dash by 2. So substitute here m1 is equal to, from this we can find m1 is equal to 1, alpha 1 is equal to minus 3. m2 is equal to minus 1 by 2, alpha value is 0. Therefore complementary function is equal to e power minus 3x f1 of y plus x plus e power 0x f2 of y minus 1 by 2 into x. Then particular integral x into e power y if we have, bring the e power y to front. So no x term is having. So replace d by 0, d plus 0, d dash by d plus 1. So after replacing, we get the result like this. Then use the binomial expansion. So right here, then x plus 5 x square by 4 x cube by 3, then you have to